Today, we're going to dive into the body's really delicate balancing act, a condition where something as simple and automatic as breathing can actually throw our entire system out of whack. So let's get into it. We're talking about respiratory alkalosis. You know that feeling, right? Maybe you've panicked or you're in a lot of pain, and suddenly you start breathing really, really fast. You might have felt a little dizzy, maybe some tingling in your fingers. Well, that common experience, that's a perfect window into what we're talking about today. So it all kicks off with something called hyperventilation. But, this isn't just about breathing fast. It's about breathing out too much carbon dioxide. You got to think of CO2 as this crucial ingredient that keeps your blood's chemical recipe perfectly balanced. And when you start puffing too much of it out, that whole delicate recipe gets thrown off. And that really gets us to the heart of the issue. We usually think of breathing as, just getting oxygen in. But it's just as important for managing the carbon dioxide that we're letting out. This balance is what keeps our blood's pH level in a super narrow, very happy range. Okay, so here's the connection you need to make. When you hyperventilate, you get low CO2. That's a condition called hypocapnia. When that happens, your blood becomes less acidic. And in chemistry, what does less acidic mean? It means more alkaline. That shift, that tiny change in the blood's pH, that's respiratory alkalosis. It's a direct chemical result of breathing too much, too fast. So what sets this whole thing off? It's not always about a panic attack or feeling anxious. A lot of the time, the body is actually reacting to something else entirely. And honestly, some of the causes might surprise you. And just look at this list. The range is pretty wide. Sometimes it's a totally logical response from your body. Like if you're at a high altitude, your body's going to hyperventilate to try and grab more of that thin oxygen. If you have a fever, your metabolism is just running hot. But it can also be a big warning sign for something else, intense pain, anxiety, or even a really serious neurological event like a stroke or a seizure. Now, how the body actually reacts to this imbalance, well, that completely depends on how fast it happens. The symptoms you'd get from a sudden, rapid onset are worlds apart from what you'd see with a slow, gradual change over time. Think of your body's response like a two-stage defense system. You've got your first responders, these are chemical buffers in your blood, and they act immediately, within minutes. But then you have the heavy artillery, which are your kidneys. They take a couple of days, sometimes up to 3, to fully get in the game and restore that long-term balance. And this time lag, it's the absolute key to understanding why the symptoms can be so wildly different. And this slide just lays it out perfectly, right? In that acute phase, when your body is scrambling to figure out what's going on, the symptoms are dramatic. We're talking lightheadedness, that tingling feeling, muscle cramps, maybe even fainting. But in the chronic form, because the kidneys have had time to slowly adjust things, a person might have no symptoms at all. Or they might have these really subtle issues like memory problems or trouble sleeping that are super hard to pin down. So this brings us to the real diagnostic challenge. Identifying respiratory alkalosis itself, that's pretty straightforward with a blood test. But figuring out why it's happening, well, that's where the real medical detective work begins. Doctors have a few key tools in their belt for this. An arterial blood gas test, or an ABG, gives them a direct measurement of the CO2 and pH in your blood. They'll also check your electrolytes. But, and this is crucial, they're on the hunt for hypoxia, that is, dangerously low oxygen levels. Because if oxygen is low, that's a massive red flag that the hyperventilation is a response to a much more serious underlying problem. Now listen to this because it is so important. It's really easy to just dismiss someone hyperventilating as having an anxiety attack, but as the source material here warrants, a life-threatening condition like a pulmonary embolism, that's a blood clot in your lung, can cause it. And sometimes it happens without low oxygen. So doctors they must rule out these super serious causes before they can ever conclude it's just anxiety. Okay, so once a diagnosis is made, how do you treat it? You might be surprised to learn that the treatment actually has very little to do with the breathing itself. Here's the core principle, and it's a big one. You don't treat the alkalosis, you treat the cause. That pH imbalance is just a symptom. It's a signal from your body that something else is wrong. So you fix the underlying problem, whether that's a fever, pain, or a lung issue, and the breathing and the blood chemistry will correct themselves. All right, this brings us to a piece of folk wisdom pretty much everyone has heard. If you're breathing out too much CO2, it kind of seems logical that rebreathing your own air from a paper bag would help, doesn't it? Well, it turns out this can be a surprisingly dangerous idea. Let's just break down exactly why this is a bad idea. I mean, the logic seems sound, right? You rebreathe your exhaled CO2 to raise the levels in your blood. But here's the risk. While you're doing that, you're also using up all the oxygen in the bag, which can become really dangerous. And even worse, what if the hyperventilation is actually the body's correct response to a totally different problem? In that case, using a paper bag could actually get in the way of a life-saving defense mechanism. This is exactly why medical professionals will tell you not to do it. So, at the end of the day, the key thing to remember is this. Respiratory alkalosis is a fascinating clue your body gives you. It's a signpost, it's not the final destination. The real answer, the real solution, always lies in figuring out what that sign is actually pointing to. Thanks for joining me for this explainer.